Hi, my name is Devin Durossi, and our final project is on text-guided image generation. So in 2021, OpenAI released both the DALL-E model and the Glide model. The DALL-E model is an auto-variational encoder, and the Glide model uses diffusion for text-guided image generation. Now, the Glide model was found to be favored over the DALL-E model, both for caption similarity and realism. So our final project is on the Glide model. Now, the Glide model takes in a caption and outputs a realistic rendering of that caption and the meanings in that caption. So, as you can see, a hedgehog using a calculator, there you have a hedgehog using a calculator. The Glide model also allows for image inpainting or image editing using Clip. However, our article really just focuses on zero shot image generation. Given a caption, let's generate an image. Now, the Glide model has a few main parts. So it first needs to capture the meaning in that caption, and it does that through token embeddings. So we have our original input, our original caption, and then we tokenize that, in which we have an integer representation for each word that is an index into a vocab list. Then we train a transformer model which will provide our text embeddings later on. Now, a transformer model has a stacks of these encoders and a stacks of these decoders. Each encoder has a query, key, and value matrix of length and of the caption, or max length. And what we do is we generate each of those, and we use a key matrix for each word to query all the other words' query matrices. And doing so through matrix multiplication, we get a score that we then normalize by the size of the embedding. And then we pass that into a forward neural network and then normalize that maybe through softmax and pass that to a next encoder. And we have a stack of these encoders, and the final output of the final encoder is then fed into this encoder decoder attention in the stack of decoders. So the stack of decoders, the self-attention works the same as in an encoder block, but in the encoder-decoder attention block, what we actually do is we have our key matrices, and we query all the query matrices that were passed in from the final block of the encoder stack. And in that way, we're able to focus on not just the previous output of the decoder block, but also the previous sentence or original input sentence. And the way we can train this is we can mask certain words in a sentence and then have the decoder predict the full sentence, including the masked words. And what we're really training is a weight matrix to generate the key value and query matrices. So after we finish training this, we get rid of our decoder block and only use the encoder block. And so when we're giving a new text caption, we tokenize it, feed it into the encoder stack, and then that final output of the encoder will be our text embeddings, which are real number values for each word that kind of give a meaning of that word given its context and in that sentence. So using those tokenized embeddings, we then want to feed that forward into a diffusion model. Now, a diffusion model is quite cool. It is a generative model that can be formulated as a Markovian chain. So what we really do is go from random noise through a series of steps in order to have a clear result. And the way we train that is we kind of model the probability of the previous time step given a noise time step through a Gaussian distribution. And we have a series of training images with captions. We noise them slightly, and then we train the diffusion model to unnoise that in a single step. So what is also really cool about the Glide model is it has classifier-free guidance. So first we do that training I was talking about previously for the base diffusion model. And then Glide tried a few different ways in order to push its diffusion models closer towards what the caption was representing. First, it tried training a separate classifier on the output images and using that as kind of a loss score. It also tried using Clip, which, given a caption and an image, outputs a number that is the similarity between that caption and the image. But it actually found, rather than those two, what worked the best was classifier-free guidance, in which we actually would just want to steer our diffusion model, given a caption, closer towards that caption. So what we do is after that diffusion model general training, we replaced text captions with an empty sequence at a fixed probability. I think they used around 20% in the Glide article. And then we kind of steer our prediction towards that true caption using a modified prediction. So we have the final formula in our article, but if you'd like to see a detailed breakdown of where that really comes from, you can find that in our references under Daryawal. I think it is um, both in diffusion model beats GANs on image synthesis, along with improved denoising diffusion probabilistic models. And in that one, they kind of talk more about clip guidance along with classifier-free guidance, but the glide model really is just using that classifier-free guidance to guide the diffusion model closer towards the text caption. So what we have first is we have those token embeddings, and then we feed that first into a diffusion model that will output a 64 by 64 image. Then we feed that 64 by 64 image along with a separate set of token embeddings from a smaller transformer model into an upsampling diffusion model that will generate a 256 by 256 output image. So each of those two diffusion models we talked about follow an ADM model architecture, which builds off of the really popular UNet CNN architecture that we have an image of down here, just featuring like downsampling followed by upsampling and then residual skip connections. ADM on top of that uses a global attention layer with a single head, along with a projection of the time step embedding in each of these residual blocks. What we also have is a group normalization step, which incorporates a time step and class embedding into each residual block after a normalization operation. We have more details in this, but so putting it all together again, we have that natural language process prompt. We get the token embeddings from that, feed that into our first diffusion model, 64 by 64 output, along with a separate set of token embeddings, fed into our upsampling diffusion model to generate a 256 by 256 image. Now, OpenAI has recently become very clear about their ethics. So they've only released a filtered version of the Glide model publicly, in which they filter out, I think, names, people, not safe for work content, and a lot of proper nouns that could be used nefariously for fake news generation. But they also hide the data set that they trained the Glide model on. But according to their GitHub, or they use the same data set used by DALL-E, which is also a secondary image generation model released in the same year by OpenAI. And that really just comes from a bunch of text image pairs collected on the internet, a lot coming from conceptual captions by Google and YFCC 100M by Yahoo. So, speaking to using that classifier-free guidance, we see charts here of classifier-free guidance having both better photorealism and caption similarity than clip guidance. So our article is really focusing just on classifier-free guidance. Now, OpenAI has released a demo to their filtered model, but you can see here it's a lot smaller of a model, trained for less time with a lot less data, and the outputs are not exactly as great as the full Glide model. But the only access we have to the full Glide model are just the images provided by OpenAI. So what we did is we have a few different demos here. The first one is just an interactive website where you can just put in a caption and press submit and then get the filtered Glide model output result. As you can see, it's not too good. But we also link to the collab file that OpenAI released that has a smaller runtime as long as you follow running it on a GPU. We also released our own collab file, which has the filtered model by Glide, along with a community recreated smaller version of the DALL-E model, so you can compare the outputs of each of those. My teammate is also working on a separate collab file that will take that 256 output of the filtered Glide model and then do another upsampling diffusion model on top of that in order to maybe incorporate more details of those text captions into it. Because as you can see by this Glide filtered model, it lacks a lot of the details that the original Glide model provides, especially when it comes to shadowing and including everything in that original text caption. Thank you for listening. If you'd like more information, please read our blog and the references down below.